So BJT and FET application. First one, you want to know. So far we were discussed about that op-amp power supply, about that one. Okay, rectifier. Another one is okay, constant voltage regulator, variable voltage regulator. These are the record the power supply. Okay, next one is op-amp. So op-amp means it is a amplification purpose you have developed for that one. You have see that one 741, one of the very oldest op-amp. Okay, this is you can use, and the input is a low signal, output is a higher signal. It is a produce. How it is a produce? Because of the op-amp. What is there? Okay, because it is a do as a addition, subtraction, integration, differentiations. How it is developed for higher signal as an output? So higher signal output, how it is developed means output is equal to gain multiply VD. Gain multiply VD. What is a VD? VD is nothing but so VD is nothing but here is a plus terminal and the minus terminal. Both the terminal you will going to apply the source. Both the terminal you will going to apply a source to the plus terminal and the minus terminal. The comparison. This is a voltmeter. This is a voltmeter. What is a VD? VD is nothing but a voltmeter. So it's a thinking about that one. It's a differentiation of these two. So that is called VD. So VD multiply with the gain. What is a gain? So they will ask you question, what is the gain of the op-amp? One more questions, 10 to power 5 to 10 to power 6. So their gain. So VD multiply 10 to power 5, then that is called output. So that's why your output of the waveform, you can compare with the input, which more output is produced. So this is the op-amp. Okay, so op-amp only do for amplification. Op-amp only do amplification means no. So BJT and FET also do the amplification. Yes. So BJT and FET also do the amplifications. So both this BJT and FET also do the amplifications. Okay, it will do on the amplifications. So that's why we are going to see about that one in this unit. Class A amplifier, class A amplifier, class B amplifier. So that is a class B amplifier. The see that one class A amplifier, class B amplifiers. So another one is these are the applications. So Darlington pair and a differential amplifier. Okay, so BJT, you can take a BJT, bipolar junction transistor. So FET also it is come under the power transistor family. Okay, come under the transistor family also. FET, MOSFET, IGBT, these three devices come under the transistor family. So either you can take the BJT or the FET, both any one you can. Okay, both also you can take. It is also do for the amplification. It is also do the amplification. How you will going to do the amplification? That is why we are going to see about the introduction. So introduction class, what we will going to see. So this is why we were discussed about already. So BJT is a bipolar junction transistor. T for the transistor. This is called a transistor. Generally, you have seen that one. There are two types of the transistor. One is a N channel transistor, another one is a P channel transistor. N channel, P channel. N is a first alphabetic order. First is N is coming, then second one is a P is going. So first you will going to taking the information. Okay, you will going to take the food. Okay, take the food inside your healthy body. Okay, inside the body, and then you will going to exit on that one. So that is a N channel and out. I mean N and P. N is called a, so arrow is going in inward direction. Arrow is going inward means taking the food. Okay, inside the body, and then the outside. Okay, it will going to, okay, I mean eliminated. That's just you are going to do the vomiting or whatever you are going to extra. I mean move away outside. That is called the outside. That is a P channel. So alphabetic order, first is N is coming, moving inside. Then after that P is coming, it's a moving outside. That's why N channel and the P channel. So right is a N is center line and the P is a center line. Then what is another terminal? P you can write. So here P is written means N you can write. So PNP transistor, NPN transistor. There are two types of the transistor. So this is a transistor. If I have see that one practically, this is a transistor. It has the package name. It has the package name. It's a TO92 package. Its name is called a TO92 package. Package means it is a looking the design. This type of shapes available means it's a package name is called a TO92 package. Whenever you will go for that buying this type of transistor, PC541. So the transistor I need for that PC541. That is called transistor PC541. So TO92 package you can give me. They will going to give that once. Okay, coming to that one transistor, what is the consist of? Consist of three terminal. What are the three terminal? Base, collector, emitter. Base, collector, emitter. So input you are giving to the base terminal. Input is you are giving to the base terminal. Okay, input is a base terminal. So collector to emitter is output. Collector to emitter is called a output. Okay. So this is about the output. Okay, and one more things I will going to tell you. Okay, so it is a NPN transistor and a PNP transistor. There are two transistors with based on that arrow. My arrow is going inside, okay, inside, and arrow is coming outside. Okay, then I will going to see next one. There are three terminal: base, collector, emitter. There are three terminal of the transistors. And the purpose of the transistor, there are two purpose. One is a switch purpose, which means on and off the purpose. Then second one is amplification. Amplification means it is similar to the op-amp. It is amplifications. Then you have see that one, so common base, common collector, common emitter. This is configurations wise you will going to make the design. So one is the base is with respect to the ground, or as a collector is ground, or collector is a center point, or emitter is center point. So like about the configuration is developed. So particularly amplification purpose, yeah, common emitter is suitable one. Okay, there are three regions. You have to see that one generally the transistor. If you're going to attend the interview question, they will ask you, so what are the region? Cut off region, saturate region, and active region. So cut off, so off period, on period, active region, amplifications. So like about that, this is general introduction about the transistor. Further, we're going to continue about that one. So this is a transistor. So here is a transistor is a base terminal, collector terminal, emitter terminal. So where is the input means this side is the input. So this is a input. So transistor we will going to give the, it's a current control device. One more information you want to know, it's a current control device or voltage control device means, so it's a current control device. Okay, current control device. So what is a current control device? I will going to teach you. These are the introduction about that first topic. Then I will go ahead on the further. Okay, so what is a current control device means? So here you will going to give the current pulse to the base terminal. Then only what will happen? It will going to allow control. Come on. Okay, so here, okay, it's a current control device. The BJT is a current control device. Somebody is not muted. Please mute. Hello. Somebody not muted. Anything want to say? So BJT is a current control device. It's a BJT. It's a transistor. It's a current control device. What is a current control device means? Current you want to give to the, this is the input. What is the input? Base with respect to emitter. It's a input. So you will going to do the triggering. Triggering. How to give the triggering? So one source I will going to take. Okay, it's a source, a DC source. You can say. So DC source is connected to this point, and I will going to connect it for that one resistance. So resistance I will going to give that once. That's all. So this is a give the resistance when I will going to vary the resistance, the flow of the current is varying. When I will going to vary the resistance, the flow of current is varied. So once the flow of current is varied, okay, so it's a flow of the current is varied. So the required amps, for example, it will going to record for that one is a 3.5 milliamperes, 3.5 milliamperes. So when this ammeter is coming 3.54 milliamperes, 3.5, okay, 3.5 milliamperes, 3.5, okay, 5 milliamperes. So when it is coming the 3.5 5 milliamperes means the transistor is here is on. What is on means you will going to make the circuits. So here is a one lamp you can connect it. Okay, one lamp. Okay, LED lamp. Okay, so everything it is see the data sheet. What is their withstand that one? So based you will going to say. Okay, so here you will going to give the power supply and the power supply to the closed. That's all. So this is about that general introduction I will teach you. Okay. So here is a source is there, source to the lamp to that here what is that one here source to the lamp to the switch to the closed. So when the switch is closed, so for example I will not apply for that 3.5 milliamperes. Suppose I will go to apply 3 amperes. So 3 amperes means, but this transistor is needed to turn on 3.5. So when it is turn on 3.5 or 3.5, when you will going to apply, then only this switch is closed. Otherwise, suppose 3 only applied means the switch is not closed, it's open only. So current is a flow from here to the lamp to the here stopping, open circuit. So open circuit, it is never flow. Okay, if you want to flow means, so 3.54 you can apply. This is called a input circuit, triggering circuit. It is called a triggering circuit, triggering circuits. For example, you were studied a 555 timer. So instead of the resistance, you may be used for the 555 timer you can use, or you can going to use the comparator IC you can use. That is the main. This is called power electronics. This is only power electronics. So this is called a triggering circuit. Triggering circuit. Left side is a triggering circuit. Right side is a power circuit. Power circuit. Okay. So left side is a triggering circuit. okay, triggering circuit, and this is a triggering circuit. It's very less amps only you want to apply. Okay, power circuit you will going to use for that. Okay, where you have see what is the voltage of that VCE voltage, you can check it, and you will going to draw. That's all. VCE, clear? Okay, VCE. Okay, so next one, I want to draw the output characteristics. I want to draw the output characteristics of the op-amp. Sorry, what is this one? Okay, BJT. So I want to draw the output characteristics. So output characteristics means when this output is a, here is a, what is this one, output color, this is a output. See, I will going to connect it to one load. Okay, I will going to use a LED load, or I will going to use a resistance load. Okay, lamp load, lamp also resistance, then source. So this is a, okay, this is source. Okay, see, this is a, okay, I want to measure the current. Okay, here you can connect to one ammeter, that is called ammeter. So what is this one? The terminal C. C means collector. So what is the current is a flow? Collector current is a flow. What is the current? Collector current is a flow. So here I have connected 1 volt voltage. I will go to connect it. So what is this voltage? This voltage is nothing but a C and E. CE. This is called a CE voltage. That is called a CE voltage. What is this voltage? CE. CE. So voltmeter connected between C to E. That's why it's a CE. Okay, next you will going to draw the curve. So output current. So I will going to draw output current. Output current. What is output current? Output current is nothing but a collector current. So collector current, I will going to write it here. Collector current and versus the so I will going to versus, I will going to draw output voltage V naught. So this is a output current and output voltage means this is called output characteristics. This is called the output characteristics. In the output one, what is our V naught? V naught is called VCE. VCE. So this is called output characteristics. Then what about that one? When you will go to, so when it is a output current and output voltage is coming, when it is current, when this power is a flow, so whenever you will going to give the triggering, whenever you will going to give the triggering. What is the triggering? For example, this BJT needed for 3.5 milliamperes needed. So when you will going to give the 3.5 milliamperes, then this transistor is closed. So otherwise the transistor is not closed. So how do you going to give? So through the resistance, I will going to give the power. Okay, power to, I will going to close. That's all. So once I will going to give that one. Okay, so vary that one this resistance, the flow of the current is a vary 3.5. This is called the input current. What is the input current? Base current, IB. So once I will going to give the 3.5 milliamperes, so output voltage. So once I will going to give the output is a flow. Okay, the output current is a flow. See that one. So here is a circuit is closed. So 3.5 once suppose I am not apply for 3.5. What happened? Suppose I am apply for 3 amps. 3 amps means the switch is closed. The switch is closed. The switch is closed. The switch is closed means sorry. 3 amps means 3 amps only I am going to base current apply means the switch is open. The switch is open. The switch is open. The switch is open means if I am going to vary that this RPS, this is RPS, I will going to say it is RPS 2. Whenever I will going to increase the RPS, the potential differences take place, but current is not flow. So the output voltage is increased, but output current is 0. Output current is 0. So my input current is a 3 milliampere. My output current is a 0. So 3 milliampere is insufficient to turn on. Then what do you want? Then apply 3.5 milliamperes. Okay, 3.5 milliamperes I am applied to the base. What happened? The switch is closed. The switch is closed. Once switch is closed, the power is a flow. The switch is closed, power is a flow. So how it is a flow? Linearly increase. So output current is increase, voltage also increase. Output current is increase, voltage is increase. After the period, so after the period, what will happen? Output current is maintained as a constant. Output current is maintained as a constant. So this is called. So here you will go and write IB. My input current I have applied. Suppose what is my input current? Minimum is needed 3.5 milliamperes. Okay, suppose I will going to apply for that 4 milliamps. What happened? It will going to rise fastly. Then suppose I will going to apply for that 5 milliamps fastly. It will going to rise. So this is called output characteristics. This is called output characteristics. You will going to draw output current versus the output voltage VCE and IC. And IB is you will going to apply input current. That's all.